And so, can any of you give me a audio check on your mics to make sure that I can pick up any of your questions that you guys ask in the recording as well?
Testing, testing one, two.
Cool. That looks like it works.
Cool.
Thank you. Uh, so I didn't get any. I guess when I proposed the session, I asked if there were any specific topics or questions that you guys had. I didn't get anything, so I kept this board at a higher level and plan to add additional content for things um, that maybe we dive into a little bit more throughout the session. Um, that way, we can kind of um, build that knowledge base together and make sure that um, the information that's kind of in here is relevant to the things that you guys care about. So I kind of kept it really high level. Um, and so to quickly go through the the way that I set up Unity projects, um, I really only have them split into a few different scenes. This bootstrap scene is the only scene that's included uh, in the build settings, and so I have this screenshot here. If I bring that up a little bit more, um, Unity or Unity projects in general, they require at least one scene to be included in the build, and so this is the only non-addressable scene that lives in my project. And this scene itself, if we take a look here, only has two things in the hierarchy. Are you guys able to see my editor here?
Yeah.
Okay. There's a main camera, which I believe is just its its background type is uninitialized, even though it's not necessary to have a camera in here. And I have this game object that I call Bootstrapper, and all it does is it takes um, an asset reference, which is a scriptable object. So this guy and kind of a prefab that it should load at application start. And so basically, we tell the bootstrapper, hey, these are the two scenes that I want you to load when the application starts, and I tell you um, with a single instance that contains all of my managers or game systems to load through the addressable system, and we mark that as don't destroy on load just in case. And so the way that this kind of works is I wonder if it'll be too small if I do a side by side here.
Oh, it's fine.
Oh my goodness. Yeah, that's a little better. And then if we look at um, this bootstrapper class here, um, all it does is it instantiates that prefab, which contains all of the game's core systems, and when that's done, it ends up loading this the game scene and the UI scene. So this is a scene loader. And so what this Bootstrapper scene does when it loads this game and UI scene. And so these are loaded additively. And so I think a good way to show this would be a good way to think about it is the game states that kind of live and drive your core application behavior. Any of the gameplay specific content lives within this game scene, and all of your UI components, your main menu, your pause menu, any loading scenes, they live in this UI scene, and that's kind of it from a scene container perspective. And I split that up this way to keep kind of my hierarchy clean and kind of differentiate, I guess, the resources that are required from both between different scenes. So there's a lot of times when you're building a game in Unity and you have to manage kind of multiple instances of your UI event list or your event system, right? So anything that has to do with UI and inputs and stuff, they kind of live within a single instance within this UI scene. And then we bridge the gap through component references, which I'll show you guys, so that these two kind of scenes can communicate with each other without having to do cross-scene references. But the restriction there is Unity only allows you to have one audio listener, and that's active across multiple scenes. You can have multiple event systems, but I found that when you do, you run into a handful of problems because you might not be accessing the current event system. And so that's why I kind of split those kind of two systems up between additively loaded scenes. And what allows these to function is the game systems prefab that's loaded from the Bootstrapper when those start. And that looks like this. So I have one game object here, which gets loaded before kind of those the game and the UI scene are created. And so I don't know if you guys are familiar with the runtime initialization on load methods that Unity has built into the runtime. But they provide you so I guess the reason why this is important is when building a Unity project, I found that it's really helpful to have a single launch point for your application. And so, in addition to having a single scene that loads on startup, um, we have a specific kind of bootstrapping process so that when you run or hit play in the editor, it'll always load that initial scene. And so we, um, before scene load, I make sure that um, I always load that bootstrap scene. So the way that like the project will run is it's always going to be a multi-scene setup, and so I always want the state of that when the application starts to be consistent. And so I want to start loading through the bootstrap scene first. I load the game scene, the UI scene, as well as the game systems, and then the game system kind of takes over uh, and goes into like any default state that I want to start it. And so in this instance, I just have like a single gameplay scene. And so the way that looks, a good way to show you guys that is I have a on that board that I shared with you guys, I have this scene switcher class. And what this does is it allows me to quickly and easily load my additive scene setup in the editor. And so the reason why that's important is traditionally you would just load a single scene, right, by double clicking it in your project hierarchy here. And I use this scene switcher editor class so that I can create the end result that my scene is going to be in when I'm playing the game. That way I can easily iterate on my gameplay loop and my UI components without having to go through and load things manually through the editor. Because what you'll see that happens if you don't do it this way, it'll be you'll spend multiple iterations just trying to open scenes and manage multiple scenes at the same time. So this is really like a time saver, and so all we do here, we load one scene as a single, and so that will clear out any existing scenes, and then we additively load the game and UI scene. And so I wonder if I can slow this down here so you guys can see how it works. Let's try that again. So you'll see when I hit play in the editor, the first thing that gets run here is this static method before scene load. And so this app class, which I also have on that board, I could do any pre-initialization of my project. And so the only thing that I want to do right now, so like when I was working on this project, I don't want to constantly have to go back to my Bootstrap scene and then hit play. So this is essentially what this does, is it will always load that Bootstrap scene in my build settings first. And so regardless what scenes I have open in my editor, I can always start from the same point. And I think that that's very important when you're building. You want to rapidly iterate on your game. And so in this example, I load some global Lua converters in Lua proxy, and then I'd load my Bootstrap scene. And even though we don't see the update in the hierarchy here, we are in the start method of that Bootstrapper class in the Bootstrap scene. And so all this does is it loads the game resources, which contains all of the game systems, right? So if we look back real quick to this, I have a single instance that is a addressable asset in my project, which contains child game objects for the game audio, the game camera, the game GUI, the game input, inventory, game logger, the game narrator, gameplay, load save, and then just a container for player data. There. And so now we can see in our Bootstrap scene here, we've loaded our game systems, addressable asset here, which has all of those, and our Bootstrapper is now asynchronously loading that game scene and the UI scene. And so now we see that we've additively loaded this game scene and this UI scene. And so the only thing that the player sees is a black, kind of a black uninitialized scene, but we're kind of loading all of these resources on the back end really quickly. And then at that point in time, we see that the gameplay system kind of takes over. And so the way that works, if I expand this project a little bit, I have my in my project, I have my scripts folder kind of split into different domain level concerns of my project. But the kind of important things here are this game systems directory and this gameplay directory. And so all of the kind of singleton resources that are going to be the core game systems that drive underlying behavior in my game, they live within this game systems namespace. And if we take a look at this gameplay resource here, we inherit from a game system base, and I think that I also included this in on the board. But what these do when that addressable instance of all of these game systems is loaded, they in enable each mono, I guess each class that inherits from this game system base will subscribe to this onloaded static event from the bootstrapper. And so all of the game systems at that point, they will have they basically have lifecycle methods that I've defined outside of the scope of Unity lifecycle methods, like start and awake. This so I call it on init, and then on shutdown are the two kind of key system level kind of methods that are run here. And so on init is called once the bootstrapper has loaded, right? So that's what we're registering is this callback. And so the reason why that's important is because the way that these game systems, like we want them to exist and be in a runnable state before kind of the player gets the ability to interact with our game. And so we do that by doing all of our initialization in this on init. And the reason why we do that here in response to the bootstrapper instead of doing it in start or awake is because I want these will run before the start and awake methods are invoked from any of our gameplay components afterward. So it allows me to access all of these game systems in the awake or start methods of my actual behaviors that the player will interact with in my game. Whereas if I wouldn't be able to do that if I used kind of the Unity lifecycle methods for these game systems. Does that make sense? And so it could probably be a little more clear here if we look at this gameplay system. So it inherits from this game system base class, and when the bootstrapper is done loading, this gameplay state says if we are configured to enter our default state, we'll enter it, and then and only then will we complete our initialization logic. And in doing so, this game system will be marked as in a ready state. And so that allows us to do some really cool dependency loading here where probably Yeah. So like an example here is that I have kind of some container classes. So like the player data, which is just a game system here, it can yield return um, a weight that says, okay, this game system cannot initialize until my load and save system is ready and I have successfully authenticated against the cloud. Um, which I think is a really important thing when you kind of build bigger, even medium sized projects in Unity, because there's potentially a lot of scene switching or scene loading that happens, and you need to kind of manage not only like your state within your individual scenes, but your kind of global application state, um, and not having something that executes within like an awaitable pipeline like this causes you to add a lot of conditionals within like your behavior classes, which detract away from, I guess, the actual like gameplay behaviors that you're trying to implement, and kind of make it harder to maintain. And so if we kind of jump back to the editor here real quick and we look at these game systems, they live outside of any of the loaded scenes. So they are, if you're familiar, don't destroy on load. I have the script, which all it does is in awake it sets it so that we don't destroy it on scene load. And then all of the game systems here are children of kind of that one instance here. And so that allows me to load all of them kind of at the same time with kind of one load call, and so I know that all of the systems kind of are initializing at the same time, and that means that because the game systems kind of wait until they are in that ready state to continue executing, that it's only when all of those game systems are ready will we transition kind of over to letting the player interact with our game. And so we load kind of the audio system, which has a reference to the sound effect pools and or I guess audio source pools. I have them split between sound effects and a music kind of audio pool, and they have different pool count configurations based on just some arbitrary values for like how often I think that I'll need to access kind of audio sources for different reasons. I have kind of the camera system, which references these fade configurations. And so if you'll notice, when my game scenes load in and out, the screen will go black. That's not using an overlay scene that's actually rendering like a 2D texture over the entire scene, irrespective of any kind of UI element, and adjust the transparency of that 2D texture so that I always know, without having to do kind of a scene load, that my scene will transition in and out, and so I control how long I want those fades to be or what color I want those fades to be through these configurations on this game system. The game GUI system, it doesn't have any inspector configurations But it maintains kind of an underlying data structure called a game screen stack, which I will show you guys, that will enable or disable the higher level kind of game screens in the UI in the UI canvas, so that I can through kind of just some function calls, I can swap things that are actively being loaded based on what UI I want to be displayed at any given time. The gameplay scene, it also maintains a stack data structure for the game state that's loaded, but those game states are defined here, and the first game state that exists within this list is going to be the default state that's loaded after all of the game systems are in a ready state. And so we can see that in this project, I load the splash screen first, and then I also have a reference to this gameplay scene, which allows kind of the game system to transition through a method call to this gameplay state, because the states are tied to potentially additional Unity scenes that needed to be additively loaded. And so you can see this gameplay scene here was loaded through a scene transition. And then if we look at this input game system here, it has, so I'm using the new input system from Unity, and so it has the player input component on it with a reference to an input action set. And the kind of game input system is a wrapper around the Unity system, and kind of gives access to the input actions themselves, but then it also sets the UI input module from the UI scene that's loaded. And I'll show you guys that too. And then this inventory system, so this is inventory might be very game specific, but this is only going to be a single player game, and so what I've done here is I basically define using a scriptable object pattern a starting inventory that the player can start with, a active item that the player can equip or unequip, and then a set of inventory slots that items found within the world can be assigned to and used, and I will show you guys how that works too. The game narrator is just a system that is also kind of gameplay specific to your game, but what I use it here for is to communicate data from my gameplay scene to any NPCs or AI controlled mono behaviors that need to interrogate the scene and do something relative to the player or what the player is interacting with. And so it's the way that I'm using it. In addition to that, is it's the primary source that feeds data into the Lua proxy layer, so that my Lua scripts can interrogate data that's happening in the scene. The load save system is a wrapper around Unity's online gaming services cloud, and so in this instance I'm just using it to use cloud save. And then this system has like these different cloud save events on there based on like load complete, save complete, authentication and stuff. And then I have Backtrace integrated in here, so so this Backtrace client, it's not mine, but it's the kind of the integration mono behavior that Backtrace includes in their kind of SDK, and so I've included it as like I need a global instance that's always available, so I've included it here in my global resources that are created. And then the last kind of system that I have that's loaded is this player data, which maintains a list. I guess it's not a list, but it has a reference to any scriptable variables that my game is using that I want to persist to the cloud save. And so what's cool about this is I have some game-specific data, so the amount of distance that the player has traveled, and then I also have some volume settings, so the master volume, music volume, and sound effect volume. And so those variables are tied to an exposed attenuation volume parameter in the sound mixer, which I can show you guys that too. But what it allows me to do is save the volume settings across clients. So if someone's playing on PC and then they log in on mobile, it'll still have kind of that adjusted volume cross-platform. And so it's really something that I would look to add for any additional kind of player options, especially if you change like key bindings and stuff like that. Does anyone have any questions about kind of this game systems object before we kind of move on?
So far, so good.
Okay.
So it looks awesome. I have just a one question because I think I didn't quite understand why you didn't put the event listener for the audio on that audio don't destroy on load.
That's a really good question. So if I stop this game, what you'll see here, so I guess to digress a little bit, Unity only lets you have, so this project is it's not using Fmod, it's not using Wwise, it's using the built-in Unity audio. And Unity only lets you have one audio listener loaded at any given time. If you have more than one, you will hear echo. And so you'll see that I do not have a audio listener on this game audio system, right? And I do that because even though this game object that's instantiated into kind of outside of the scene, it still has a transform, so it still has a position. And if the audio listener is on this game object, then that means the player is going to hear audio from the origin, so 0, 0, 0. And so what I do to accommodate that, if we look at the game audio system here, when this system loads, so when the audio system loads, we attach an audio listener to the audio system. So just this audio system's transform. right? And so if the audio listener target is a valid transform, then we do an add component call to it, and we set a reference to the target's transform that we just assigned it to. And so I do that because my splash screen has music, like a theme that's played when it's loaded, and so I need to have, like, the player doesn't exist at that point, and so I need to have an audio source that's loaded to listen to the music theme that's played on the splash screen. And so in that instance, it's not a 3D sound, so it doesn't matter where that audio listener is. But when the gameplay scene is loaded and the player is spawned, I need to transition that audio listener from the audio system to the player. And so what I do, when the player is created, it registers itself with the game narrator. Because this will basically, the game narrator, so this system will wait until we have a valid player. And so the reason it does that is because if I spawn enemies, I don't want to throw exceptions or have enemies start running their behavior when I don't have a target, right, the player. So this system waits until I've registered kind of this player instance, right? So when the player spawns, we can see that in the start method of the player, I register its instance here, and this adds the player as a target to the camera system, so the game camera, and then it also tells the game audio, hey, attach the audio listener to me. And so at that point in time, the audio listener will detach the audio listener from itself, right, the audio system, and attach it to the player. And in doing so, that now allows me to play sound effects in addition to music, because the sound effects are they're 3D sounds, because it's a if they weren't a 3-dimensional sound, right, it wouldn't matter where enemies were distance-wise away from the player. If they were playing a footstep sound, you would hear that footstep regardless of how far away you were. And so those are now 3D sounds, and because we've swapped that audio listener from the audio system to the player, it now allows the Unity application as a whole to support not only 2D but 3D sounds at that point. And so that's why I don't have the audio listener on the audio system. Does that make sense?
Yes, yes. It was a very comprehensive answer. So, thank you.
You're welcome. Are there any other?
By the way, the UI sounds are 2D, right? The one you are using?
The UI sounds, yes, they will be. I don't have any sounds hooked up to my UI at this point, but yes.
Okay, so yeah, so no problem with that. Okay, thank you.
Right, and so the way, I guess, the latter part of that, the way that these work, we have like the sound effects here. They are just, I believe, WAV files. I do not play these sound effects directly. They're not directly referenced. There is a scriptable object that I reference those sounds to, and that scriptable object contains a handful of settings which are specific to that sound effect, which will be applied to the audio source that's chosen from the audio pool when it's played. And so the reason why I do this is so that I can configure the effects, the way that a sound will sound to the player on a kind of instance by instance basis, especially if I want to reuse a sound multiple times. And so you'll see like this dash. I also have an editor script here at the bottom of the scriptable object, which allows me to preview this sound. I wonder why I don't hear it.
By the way, we won't hear it because you are sharing the screen, not the application.
Well, it's actually not playing the audio
For
me.
you neither?
Yeah.
Okay.
0.33. I don't know why that's not working. Maybe
You can fake that you're hearing a great sound.
yeah.
We will believe you.
I guess it doesn't matter ultimately why that's not playing right now. It was working at some point, but let's I do that for sound effects and musics. That way I can also control the volume of the sound that's playing irrespective of the audio channels in the mixer. Right? So if we just look at the audio mixer here, I have it split up into multiple channels. Each sound effect, now that that's open, you can see that I can specify an audio mixer that I want that sound effect to be played against. And so the really cool part about how this infrastructure for your application works really well is that using a scriptable object pattern, we can make all of the game systems and their functions and behavior available to you in the inspector without requiring that instance to be loaded into your scene, right? Because you think, I want to play sound effects, or I want to play visual effects, or I need to change the scene that's loaded, or change the UI that's loaded. How do I do that when the game system, right, in my editor right now is not loaded? Right? I have usually when I'm working on my game, I have this hierarchy loaded. You can see I do not have that game system instance loaded. And so the way that works, if I move this back over, if we look at the audio system here, all of the public methods that are exposed to the audio system are static, which means one, I can call these methods without an instance of the audio system, right? And the reason why that works is because the base game system that all of these inherit from, when they are loaded, they set a static instance, right? So they inherit from this singleton mono behavior. You're probably all familiar with singletons. In their awake method, they will set that static instance here, and it will only allow a single instance of that system to exist. So if accidentally a second one is instantiated into a scene, it'll immediately be destroyed. And so you might be thinking, well, Unity doesn't allow you to, like through the inspector, call static methods, like in a Unity event per se for a C# class. And you're right, it doesn't. And the way that I manage that, which makes this kind of architecture so powerful, is that each game system has a equivalent scriptable object. So if we look at the audio SO, the audio scriptable object, this provides public functions that call those static methods on that game system. And so you can see here this scriptable object has a method called playSoundEffect, which takes the sound SO scriptable object of the sound that I just showed you guys, right, for that dash, and calls the playSoundEffect, the static method on that game system. And you can see that within the game system, I reference that instance. So rather than have all of my game behaviors, right, reference game audio.instance.playSoundEffect, I keep all of that accessing kind of contained within the systems themselves, and so it allows my behaviors to be very clean and very explicit about the things that it wants to do without having to be really redundant to say, okay, well, this game system dot instance, and so not only does it keep that clean, but if we take a look at my player object here, what like the most powerful part about this architecture is that when I want to play a sound effect, for instance, well, I guess that's not a really good case because I just changed this today. If I wanted to play a good way to show you would be to look at this game system. So if we move away from the audio system, I guess I have an example here. But you, in your Unity events in your inspector, you can reference those scriptable objects and call those methods, right? And pass in any parameters that those systems need in order to run. And so you can see in here, when this gameplay state is loaded through the gameplay system, we tell the audio system to play this music, this ambience horror sound. And so this calls that play music on the scriptable object, right, which then calls the game system. And I don't have to worry about having an instance of the audio system or the gameplay system in my scene to set up the Unity event in my inspector, because all of that lives, like the instance is populated when the game object is loaded, right, through the bootstrapping stage, and the references live within the game systems themselves. Does that relationship make sense? Are there any questions around that?
I would say almost, because I still don't understand how can you access them in the editor time. So because
Yeah.
you're populating the scriptable object, but you still need an instance of the singleton to call or not.
So most of that is correct. I do need an instance in the editor to call, right? But I do not need an instance of the game system in the editor. Because in the editor, I'm not actually playing the game, and so the game system itself does not have to be loaded. Um, think of it as like a contract that will be fulfilled when the application is running, and only when it's running. But when we're in the editor, we don't need a system instance. We only need an instance of the scriptable object. And so you'll see in my project window here, I have a scriptable objects folder. And in here, I have a subfolder called game systems. And so this game systems, each of these subfolders in my scriptable objects directory are addressable. They are marked as addressable, and then each game object or game system has a scriptable object instance that's been created. So you'll see I have this create asset menu for each of these scriptable objects, and I only ever have one instance of this scriptable object ever in my project.
Yeah, but then you call, for example, game audio dot play sound effect. How can you call the game audio dot play sound effect with that?
So my inspector window. So in my inspector, the way that this works, so this think of it like my game architecture allows me to split my development into two different verticals. One is gameplay authoring or development, and then gameplay execution. And so when I'm authoring or working in the editor, I'm not actually running the game. And so in that scenario, I only ever need a reference to the scriptable object. And so the scriptable object has its own wrapper method around the system, right? So the game audio system. So the game audio scriptable object has a play music function, which calls the game audio system play music function, right? So I think it's this one right here. And so that's how the Unity event in the editor calls the scriptable object, which calls the game system. And then if we actually look at the game audio, so the game audio system, right, the class that we were looking at before, we see that we reference the instance here within this static method. So the scriptable object does not need an instance because the method is static, and so the method can be called from the scriptable object without an instance. And then if we transition from the editor into runtime, right? I can go, if I put a breakpoint here, and I hit play. We run through the application Bootstrap, right? So we load our Bootstrap scene, and then our Bootstrapper loads all of our game systems, right? So that game system prefab, and then I want, here's the on init, and then there's the start, and then here's the attach. So we'll see where it goes next. So we'll see the audio, so the game audio system start is called next, right? And we just do some guard checks to make sure that we have a reference to our audio source pools. And then we hit on init, right? And so this is, if we kind of look at this call stack here, I don't know if you guys can see that text, but we have the Bootstrapper onload complete, which is called once the game and UI scenes are loaded, and then we invoke that onload event, right? And so that calls the onInit function in each game system, right? And so what that does is it basically runs a coroutine, and when and only when that game system coroutine onInit returns will this game system be marked as ready. And so we can see that we are in the audio game systems onInit, and we are in the attach audio listener to that audio system, right? The initial execution here, and now we finally kind of, where if we look at this watch window here, we can see we're trying to play the music splash theme, right? It's a scriptable object, and we can see that if we step up this call stack, we can see that our game state, so this is the, I don't know if I can click that. So that game state that I was showing you the Unity event on in the game scene, we can see that we are in a onInitialize method, right? We invoke the Unity event onInitialize, which is the one I was showing you, and we can see that that calls the audio scriptable object here, right? So this is that play music function I showed you on the scriptable object. So that's calling this scriptable object in the editor over here. And we see that this calls the game audio play music function, right? Static method. Like, that's important to recognize that this is a static method on the game audio class. And when we get in here, we can see that our instance has been set to the audio system on the game system's game object that was loaded by the Bootstrapper, right? So if we look at, if we just pull this up, I want to. I can't pin it, but you can. So we can, if we just look at this, the instance here, just so that you can see, we can see the scene path is prefab game systems clone audio, right? So this is that game systems prefab that was loaded by the bootstrapper. And that instance has a reference to the sound effect pools. And so this static method internally is accessing the static instance of the audio system to gain access to the inspector assigned fields, right? So those audio pools. Does that make it more clear? Right? Because this
Yes.
okay, because this instance is only ever going to be not null when the application is running, and
Yeah,
so
on
this,
runtime.
yeah.
Yeah. But what I thought is that if you play on editor time, let's say, it would be able to play that music and sound and position. That's what I thought. Like in with the scriptable objects.
Oh, I gotcha. Yeah. So, the way that actually works, I can show you. That preview doesn't use the audio system. There is a custom editor that I wrote called Preview Sound Editor, and it's a custom editor for that sound SO, so the scriptable object, and it adds a preview button to the bottom, and what it does is it gets a reference to the scriptable object that the custom editor is being attached to, and it creates an instance of a audio source that is hidden in the hierarchy, right? It has, when we create object with hide flags, we set hide and don't save. And so behind the scenes, Unity is actually creating an audio source when this inspector window is loaded and we're looking at that sound effect. And when I click the button, I basically I call this preview sound effect function on the sound SO. And so there's just this all it does is it takes the audio source that's kind of hidden in the hierarchy, it applies the audio settings to the audio source, and then it moves I think it's here. So before we call the preview sound effect, we actually move the hidden audio source a specific distance away in the scene from where we are, and then we preview the sound effect. So this will apply the properties to that audio source, and then it will call play. So the preview doesn't use the audio system as the game system.
Oh, okay.
If that makes sense.
Yep. Nice. Yep. It's awesome. Why?
And so just to go back a little bit. So here's that onInitialize function. So there's the game state, game splash, right? So there's a component game state, which has these lifecycle events, which are called by the underlying game system when we add or remove game states. So the way that you can kind of think of my game right now is I have two game states that kind of exist. One is the splash screen, and then one is the gameplay. So there are two game states that my application can live in, and then on top of that, there are multiple UI states that my gameplay can live in. And so I have a gameplay, I call those game screens. And so those are gameplay, which show like the game, the player UI, right? So the health, the distance, the items and stuff. The pause screen is its own game screen. The option screen, where you can adjust the audio, is its own game screen, and then the splash screen. And so, whereas all of the game states that live in the game scene are siblings, when you look at the UI structure here, they are not siblings. They are children of UI canvases. And I do that because I can, on the canvas component for each of these, change the sort order. So I can always make sure that different UI elements will be displayed kind of above other ones without having to hide or show different UI components, and I'll show you kind of what that looks like. But that, if we look at the gameplay screen, we have a custom data structure called a stack, which takes a generic game state SO. And so this is, I guess the thing I don't know if you might be wondering, but the thing is, Unity does not by default allow cross-scene references. And so you might be thinking or have experienced situations where you want game state to drive transitions in your UI. And you think, well, how do you do that when you have your game state and your UI state kind of living within two different scenes? And so I do that through a scriptable object pattern that actually has scene references built into its data structure. And so that's a really important concept to understand and how this works. Because if we compare the audio system and the gameplay system side by side, I interact with them in the editor in the same way. And so we can see we have some other references to other game systems, right? They're scriptable counterparts in the inspector. I have the gameplay scriptable object here. I have a GUI scriptable object here. Same thing for the splash screen. I have the audio and the GUI system here, and we'll see, just so you can understand how the application loads. Right, we start in the splash screen, which shows the title, and then you can press any button to start. Right, and if we expand this game object, I have a component which actually plays that confirm start sound, and then it also tells the game system or the gameplay to load the gameplay state. And so you'll see if I run this and I clear my breakpoints. If I don't press anything, we actually don't have that gameplay scene loaded. If I pause this and I expand these, from a application runtime kind of perspective, we see that we are in. So you can think of a game state that's active is a state that is active and on kind of the stack of states that are updated. Anything that's disabled are not. Same thing with the UI. Any game screen that is active is shown to the player. Anyone that is inactive is not. And so if we take a look back here, when it detects this any button press, it'll tell the gameplay system to load this gameplay state. And so if I unpause this, we can see that these states are flipping around. So we see that the game splash state has been disabled, the gameplay state has been enabled, the splash screen is now disabled, and the gameplay screen is now visible. And that's what we get when it executes, when it runs. And you might be thinking, well, how does that work? Because you're referencing a scriptable object here, right? This gameplay game state in your inspector window, but you are enabling or disabling this gameplay state in your actual game scene, right? So your mono behavior, your instance. And so if we kind of take a step back and analyze the reference I told you about, that the game states and the game screens have a component reference to those objects within a scene, we can so this game state in the inspector, we see that we have this what's called a GUID reference to a GUID component on that game object, and that it has a containing scene, right? So in our instance, this scriptable object is referencing this gameplay game object, right? This instance in the game scene, right? And so if we go back to that game state, now that you might be looking for it, there's a component that lives on all of the game screens and game states within the project that have a unique GUID. And so there is a let's see if I can find it. Is it a plugin? I don't think so. There it is. If I go to I found this library on GitHub a long while ago. I think this is it. What this allows you to do is reference game objects within a scene in your scriptable objects. But it doesn't have to be specifically referenced in that manner. You can support cross-scene references, so from one scene to another. I don't use it that way. And the way that resolves is if the scriptable object is trying to access that GUID reference and the scene is loaded, it'll return that instance. If it is not loaded, it'll return null. And so when I am authoring or working in the editor, I always have this additive scene set up, right? And so I will always have kind of the instances that I need to reference here. And then their corresponding data structures. So each game state and each game screen has a scriptable object that references that GUID component, right? And it's that GUID component that allows the game system to find the game state based on a given scriptable object to enable or disable that game object in the scene. And when I say that, I just mean we have this game state scriptable object, right? This game stack here. If we look at this, like what is this game state in a scriptable object form, it has some wrapper fields here. And it has kind of like a few different methods. We have an initialize method, which is called by the stack when we add a game state in this scenario. And when we do that, you can see that we access that GUID reference, right, which has an instance of game object, and we set it active to true, which will enable it in the hierarchy. And then we also have a exit function here, which is called when the game state is removed from the stack. So whether we pop it from the stack or we explicitly remove it, it's called. And we can see that we also reference that GUID reference game object, and we set it active to false. And so I know, based on how my application bootstraps itself and loads the game scene and the UI scene, that all of my game screens and my game states will be loaded and available to the game systems. And so I always know that as long as I have created a game system or a game state mono behavior and a game state scriptable object, that when I'm running the game, I will always have a valid instance that I can kind of load or unload. Does that make sense?
Yes.
And so we can reinforce that again by looking at the game screens. So the game states themselves, like the underlying data structures that's used to support both game states, right, that drive gameplay and player interaction, and game screens, which drive kind of outfacing information to the player, right, through UI elements. They're built on the same data structures, and so we can see that the game UI, right, this game GUI system here, it works in the same exact way as the game state does, only there are some mechanisms built into it that support the ability to auto hide game screens. So what that allows me to do is if I just want to display like a message for a short duration, I can do that by just saying, hey, show this toast or this message for some configured duration, 3 seconds, 5 seconds, and then auto remove it from the game screen stack. But other than that, the underlying data structures are exactly the same, so they'll function the same. And so we can kind of see that work here. If I press escape, the escape key in this game, I will pause the game, and I have a event listener that looks for that pause event, which is invoked from the gameplay or the game input system, and tells the UI to show the pause screen. And then when I am unpaused, right, so I click resume or I click escape here, it tells the UI to remove the pause screen. And then you can see kind of briefly, that the if we just expand those a little bit, you can see that working, right? You can see the pause screen show. If I click options, you can see that we overlay the option screen on top of the pause screen. And if I go back, you see those kind of operate in a stack-like fashion to enable and disable those in the hierarchy. And so that's the way that the game screens and the game states kind of work. They're probably the most complicated part of the application architecture that I am using today. And so like if we look at some of the other game systems, they are not as nearly as complex. If we take a look at the game camera here, we have a reference to those fade options. And I'll just put that up on the side here. They basically just contain duration and color, pre and post fade duration, and then we split the camera system up into screen fade and targeting. And so this is the logic that will create a new fade texture, which is just a completely black 2D texture that's kind of overlaid across the whole screen. Right, so this is working in not screen space coordinates, but is it frustum, view frustum, right between 0 and 1, and then it has kind of some methods in here to fade in and fade out, and so these are called by that scriptable object, the camera SO, right? So I can hide and show individually through that way, or like for the game states themselves, I believe that they actually they call the fade in and fade out methods automatically, so that when the game states load, they if you're using a level game state, they will load a Unity scene in addition to doing a game state transition. And so I don't want you to see that scene load. I don't want kind of that content to pop into existence out of nowhere. And so the game states in that situation, they will fade the camera out and fade the camera in when they need to load another Unity scene. And then we have targeting methods, which add and remove a transform from the Cinemachine target group. And then if we look at the game input system here, we have a this is a input, like the input action map that you saw in the inspector. We have it configured to where is it? To generate C# classes. I think it's here. So this is, when you're working with the new Unity input system, this is what your action controls, or your action map, is going to look like. If you look at it in the inspector, there's an option to set a class namespace and to generate the C# class. And so I do this because I want to be very explicit when those input actions are enabled or disabled, right? So enabling or disabling player input or player interaction with objects in my scene. And I want it to coincide with the input system startup. And so we can see that the input system, it waits for the game GUI system and the game camera system to be ready, because it wants to set the UI input module and the camera on that player input component that you guys saw from the new input system to the references that those game systems have once they're up and running. And then we enable the player controls here, and those are made available to kind of my mono behaviors, right? So the player class through these public accessor fields here, which are just wrappers around the input actions, right? So the player controls, combat, use, and so that exposes the input callback events. I think they are started, performed, and canceled. And so if we look at, just to give you a quick example, when my player is enabled or disabled, we reference those input actions and we call or we register callbacks for those. So the reason why those live on the input system, like a singleton game system, instead of adding input actions as a serializable field on the player itself, is because I've gone that route before, and it if you're not careful, you end up putting input actions on things that are other than like your character. So like interactables that the player needs to interact with, or items like items or weapons or consumables or things like that. And it becomes really difficult to manage where your input checks are coming from. So one, not only like what are the bindings that are bound to those input actions, but where do they live, especially if they're on prefabs that maybe are not instantiated in your default scene, and they are just kind of referenced and instantiated during runtime. It gets really tough and difficult to manage, and so I found having a single interface for those input actions is really helpful and allows you to kind of only interact with those in your mono behaviors in a very like contract driven way. And I think the last thing that I'll say that I actually started to do, and I haven't finished transitioning this input system over to completely, is the new input system does not allow you to simulate player input. And so the problem I was running into, in order for this pause menu to work, I wanted you to be able to, you can pause the game by pressing the escape key, but I want you to be able to dismiss this pause screen by either pressing the escape key or clicking the resume button. And so pressing the escape key dismisses the pause menu through the bound input action on the player controls, right, through the Unity input system. But pressing the button here does not, because it's a Unity event that's configured on this button, right? So there's a Unity button here, and this says on click I want to toggle the pause state. And where the new input system breaks down is that there are like I didn't want to manage different sets of bindings based on the way in which the player was going to interact with the input system, right? So if you remember, you saw that there's a component that is called invoke on pause, and so I wanted to bind this component to the pause action on the input actions, right? So that when I press the escape key, it will show the pause menu, and when I press the escape key again, it will hide the pause menu. And that worked great until the player presses the resume button, because the resume button does not, it cannot simulate a user's input. So that pattern kind of breaks down, and you would have to have, I guess, you would have to have the invoke on pause bind to something else within the game input system to support that behavior, or have like a cross system reference between the mono behavior and the input system in a different way, or an additional way. And so what I did is I created a for this pause input, I created my own class called a input action event. Which takes a input action as a parameter in its constructor, and basically wraps the lifecycle callback events of the input action, and provides the ability to register and unregister listeners to those events, and then manually raise an input event. So I call it a input action event type, and they just mirror the input action of the input system, right? So started, performed, and canceled. And so we can see how that works by the invoke on pause will register and unregister a callback listener to the performed function here. And then when the game input kind of loads, it also registers its own listener to the on pause started event. And so that allows me to also manage kind of the cursor state behavior, because I override the mouse cursor in my game, and I set the timescale to 0 when the game is paused. I have that logic live in the game input system, and those get updated when the input action is invoked. But when the button is invoked, we call this toggle pause, and it allows me, having that kind of wrapper around the input action, I can manually raise those events myself. And so in effect, my input, anything that kind of registers itself as a listener to input actions, they will be notified when a native input action is detected from the Unity input system, or when I manually raise an event. So this will get called in both scenarios at that point. And so I just created that that implementation, the input action event, the other day. So I haven't gotten around to setting the other input actions up. Are there any questions about the input system and why it's kind of exists in that state the way it does? I guess is anybody using the new input system today?
Yes, yes. Actually, I'm using it. I understand completely the problem you're trying to solve in here, and I feel a little bit like it's over engineering the solution. I don't think the problem is that great in maybe in small games or medium games. Maybe in medium could be, but I think it solves the problem that you are having, because what you're trying to do is like to center all the input in one script, which is quite difficult when you have a lot of menus and different states where the same buttons need to be used for different things. And when you don't want to have different controls in different scripts, this could be a solution for that. And,
Yeah,
I
yeah,
think
that's
it's solved.
exactly it. Because the reason, I guess, the reason why it's written that way, especially with this input action event, is because it will also work with key rebindings. It will also work with multiple action maps that are bound to different input devices, right? So between keyboard, mouse, and gamepads, and joysticks and stuff like that, and it will allow me to simulate kind of player input outside of, right. So this is a severe example, just for to get a pause menu to work. But if you think
you're
about,
mocking, for example, in testing,
yeah,
it could be a great example.
yeah, it could be really good for testing, and running character input during cutscenes without having to do like animated timelines. You could just do you could run the same inputs that your player uses already, and like now you're relying on the underlying mechanisms to make the player move, so they're always going to move at the same speed in the particular direction that you want, because you're using the input system instead of having to simulate that through timeline.
It has its uses. In my case, I see that it's not that cumbersome, or it could be like not that a problem if I have scripts for example, for controls, and so I already know where are these inputs coming from, and not like any object that's spawned or from a prefab, or as you say, like you don't have any control of where the inputs are read from. So I think it could be not not such a great deal to deal with. So, for example, I could have a control for the pause menu, like in a different input script, and it won't be, for me at least, it's not that complicated to match that if I know that, for example, the menus, every menu that I want to use will have their own input and controls, and I already know that there will be a script that is with that function, let's say. But I understand if I, for example, one item that's spawned, it could be some problem if it has its own control and stuff. But until that, I think it's manageable with the new input system to have different key bindings and different things without using like, I would say this is a wrapper of the game input.
Yeah, that's a good analysis of it, and I think that that's perfectly valid. It really makes sense when, like, you have those behaviors that are really tied to those individual components that are in your scene, right? And I know with my Deep Sea project, that's the route that I went, kind of in that project. And I think that it got really funky for me when I had multiple inputs bound to the same kind of gamepad or keyboard inputs, even though they were different input actions. Especially when, like in Deep Sea, you can interact with your equipment and your inventory to equip and unequip items, but then also use basically the same inputs to use the item, and then those inputs are also used to capture movement and move and animate the player. And so there was a lot of there's a handful of control methods which are tied to kind of animation events or
fishing,
different behaviors
different things.
that enable or disable those individual input actions on those behaviors based on kind of the player's state, and that's something that I wanted to try to avoid here.
Yeah, I feel that. Yep. So yeah, it's a great solution for them, by the way, like having this wrapper. And actually, see, as I said before, for example, for testing and for mocking the input, also is a great solution because you can easily do that with this.
And so
By the way, no questions from me.
Okay. So we'll move on to kind of the next kind of system in this architecture. It's just the game inventory here. It uses scriptable object pattern to not only keep track of the total inventory that's available to the player or what their starting inventory is, but also their equipable item and those item slots. And it has methods on here to when the game system loads. So the game inventory system here is the first one that you'll see that interacts with the load save system. So we wait for the input and the load save system to be ready, and we implement a iLoad save data interface, which makes these on save, on load, and on unload methods a data contract with the load save system to load inventory from cloud save, and then on load eventually use that save data to rehydrate your starting inventory. We're not doing that now, but it's written to do it. So if there are, like, you've gained so much experience that you've unlocked additional weapons or something like that, those items, right, their unique identifiers and their quantities would be saved to the cloud save and reloaded in here. And then we just have some methods to add item to the inventory, drop items from the inventory, and remove items from the inventory. And so these kind of respect a max kind of quantity that can be configured per item. So if you only want your player to be able to carry maybe 5, like a stack of 5 of like potions or something, it respects those. And we can see that here. So the three items, or the three squares in the bottom left, they are empty inventory slots. And when we pick up this this pistol or rifle here, we can see that it gets added to that item down there. And you might be thinking, well, how is that UI element referencing that that information? And that's through a scriptable variable. I have a custom variable here called active item, which references a type of equipable item. And there's a event listener on each of these item slots in the active item, which is attached to the player, to be called when the scriptable variable value changes. So when we equip an item, the inventory system will set the scriptable variable, right? So that item slot equal to the item that was equipped. And then when we equip the item, it'll set the active item value of the scriptable variable to the item that's in that inventory slot. And then we keep track of basically the slot index of the item that's equipped. Does that make sense?
Yeah, definitely. So I think this was from an architecture with scriptable objects, from a GDC talk, like a very old one. Or
Yeah. I think it was like from 2015 or something. It's very similar. Yeah. I had written my own scriptable variables for Deep Sea, and then I saw, like, I fixed some big edge cases in a scriptable object kind of paradigm, and then I saw that there's an asset called SOAP. Looks like this. Scriptable Object Architecture Pattern. This is on the asset store, and I switched over to use this instead because
is
they
it free?
do. It is not. It is not free. But I switched over to use that because they had implemented custom editors for their scriptable objects, and their inspector editors for variable binding were better than mine. So if we just take a look at these, we can see not only do we have a value or initial value, you can clamp it. You can set when you want this variable to be reset, so on scene load or application start. And it actually keeps track of where that variable is being referenced, which is great. I think initially when you do scriptable object pattern, especially when you use it for events, it when your project scales and gets really big, you can have a really hard time debugging where those events are on your game objects in your inspector, and where your mono behavior logic is being called from those events. And so I thought that this did a really good job. And so you'll see here that I have in the game inventory, I reference this item variable, which is a custom variable that uses it inherits from the SOAP scriptable variable, but uses my own custom scriptable object type as a generic. And it just works, which is pretty cool that I could extend it that way. The game logger is just a wrapper around the debug.log, but it allows me to each game system has its own kind of configuration to enable or disable logging within that within its own system. In addition to enabling or disabling debugging on the application level. So if I really need to enable debugging for everything, I can just enable it on the app. If I need it on an individual, like a very small basis, I can force kind of the logging here, and then I don't have to add a additional namespace and have debug.log kind of around my application. I can just use this kind of gamelogger.log system and have it log or not log based on the game system's configuration. So I don't have to do a bunch of conditionals within the game system that says, oh, if this game system is configured to enable logging, then log. I have that kind of contained in here. The game narrator system, this is the only game system that actually has a Lua proxy, so that the Lua side, so the enemies that are controlled by a Lua script can interrogate scenes, right, and tell the thing that it wants to move or stop. This just has some methods to like get direction to the player, get distance to the player, get a random direction, but there are in some of my other projects, I have a lot more kind of AI behavior methods that I'll look to add based on like, is the player looking at me, or are they looking in an opposite direction, or like how fast is the player moving, or stuff like that. So that's kind of where all that kind of logic would live. We've looked at the gameplay system here. Then the load save system is a wrapper around the UGS cloud save. And so when this system kind of boots up, it will initialize with the Unity services and do a anonymous authentication. And it has not only a ready state, but it also has a authenticated state. So when the player data is set after a successful authentication with the Unity authentication platform, will this kind of system be ready and authenticated? And it has some methods to load and save data from the cloud. And you can kind of see how those kind of work. Looking at the player data system here, we see that it implements the iLoadSave data interface, and in its initialization method, it adds itself as a loader and a saver to the persistence data structures of the load save system. And basically the way that kind of this load save architecture works is that the application allows any kind of system or mono behavior or component within the loaded game to implement these interfaces and add itself as a loader or a saver. And that just means it gives those systems or mono behaviors the ability to persist data by returning a data structure of information that's relevant to it, or set data on load based on previously saved data that is relevant to it. So we can see in this scenario, I have the distance traveled, the max distance, and then the attenuation volume for each of those overarching audio mixers referenced as scriptable variables, right? And when this system loads, if we have saved data, we will set the values within those scriptable variables to the save data. And if we don't, we'll simply return. But when we save the game, we basically bundle all of the data that we care about. So the attenuation volume and the max distance, right? Compared to the current distance traveled and the max distance traveled that has potentially been set by a previously loaded game to be saved, right? And so these methods on save, on load, and on unload, they are called by the load save system at the points in time in which it needs to, like a save or a load has been initiated and it checks a load and save persistence data structure, which is just a dictionary of unique keys to fetch data from anything that's registered as a saver or a loader, and save or load the information that they return. That way, the save system doesn't have to care about data structures or data types or any type of specific gameplay information. It just needs something to be registered as a loader or saver, and then all of the data that those subscribers kind of care about, they can manage and manipulate that kind of content, because the loader is just gonna like if we look at the save here, it's just gonna go through each instance that's been registered as a saver in the save persistence. It's gonna call the onSave method, which in our instance of this player data, it's gonna return this save data class, which has it pulls these variables from the scriptable variables, and then it calls a try save on this save system, which all this is a static instance of a wrapper around the cloud save. So if you're not familiar, Unity Cloud Save has a key value pair data structure that you can load and save to, or load, save to or from. And so it works in specifically data keys and hash sets. And so I abstracted those kind of data contracts out of my save system into this kind of iSave system interface. So they will always have a try delete, a try get all keys, try load, and try save. So, and I did that because in DeepSea, I use the same load save system, but the underlying data or the underlying storage is actually file system based using Easy Save. So rather than calling Cloud Save Service, I have a Easy Save wrapper, and then I also have a local JSON file system that I wrote before I was using Easy Save. That I also have an implementation for. And so that's kind of how the persistence works for like on a player by player basis in my game. Does anyone have any questions kind of about that? Okay, and so I think that's generally an overview of the application bootstrapping process, how we kind of load the underlying Unity infrastructure right to support kind of my gameplay, and then the individual game systems that are loaded and how they kind of intercommunicate between each other. I think anything else that we discuss might be more gameplay specific, how the gameplay is kind of built on top of those things. I'm open to any additional questions that you guys have. If there's anything you've seen that you want me to extrapolate on, please let me know. What are everybody's thoughts and opinions?
Okay, there are no claps emoticons in here. Oh yes. Well, I didn't find them. But yeah, it was a great talk, let's say. And lots of useful stuff. And actually, yeah, you can have lots of questions of every one of the systems, but yes, they're out of scope maybe because it would take forever if we deep dive in every one of them.
Mm-hmm.
And yeah, I think it was a very good. Actually, it was great to have this for the first talk, so we can have a whole idea of what's going on with this kind of architecture, and later on we can ask you about the specific things of it. In the
Yeah.
meanwhile, we can see the the playthrough of the game. Nice.
Yeah, absolutely. So like I said, there wasn't a lot of feedback initially, so I wasn't sure how we wanted to target um, the kind of information, and so I didn't put a whole lot of content on that board. And so I think that if there are specific topics or things or architectural implementations that you guys are more interested in than others, let me know and I can add them to the board. I included some of the bootstrapping core infrastructure that I use in my project on that board. I don't have like the actual implementation of my load save system or the underlying data structures for that are used by the game state or the game screens and stuff like that. But I'm more than willing to share that content with people. I really want to, I guess, leverage my experience and expertise in the things that I've built to make kind of my applications run and scalable, and fun and easy to work with, available to you guys. And at the capacity that I can, like, just let me know. I've even been considering maybe doing, try to budget in one-on-one time if people would find benefit in having like a one-on-one session to do certain implementations in their game or work through problems or something like that. I was kind of thinking about opening that up as a possibility. So I don't know. I guess I'm curious to see what people are individually looking for, or as a group, what you guys are looking for. And I think that's kind of about it. I won't keep anybody much longer. But yeah, you can see on here I have that game going here. This past week so we see we're using a spotlight over the cart instead of a global thing, and we see I have the spline for the level being generated. I haven't gone this far, so there are some old splines on there and that I need to address, but there is a train track sprite that's being added. Looks like I broke it, but you gotta get you gotta get the gist of it. And it persists every time that you enter a new level segment. It will save your current, like your max distance traveled, so it keeps track of that kind of that data right through the player data structure. You should be able to see, I don't know where the last save point was, but when that UI loads, we can see that we made it 13.48, whatever the distance is. That's actually being loaded from Cloud Save, right? So the last thing that I'll show you guys is, where is the get started? Let's sign in. Under Live Ops, we have Cloud Save, so we can find player. For my game, I create a development environment, and when I'm in editor, I always set that to be development when the load save system loads. And we see last login was July 3rd, so that's this person. And if we go to Cloud Save, we see that I'm saving game inventory and player data. My game inventory doesn't have anything in there because I'm not leveraging it at this point. It's just a subscriber. But if we look at the player data, I'm just serializing some escaped JSON here. So we can see max distance traveled 13.4812918, and then the volume settings. And so this is the JSON that's loaded with the data type, right? Oops. when that load save system is initialized and we call load. And I do that. Where am I calling load? I think I'm calling load. Not in there. I think I have a. There it is. I have a event listener in my game scene called invoke on authentication. So this hooks into the on authentication success event of the load save system. And when I am successfully authenticated, I will call load game. And so that actually happens when, like, right around when the splash screen is loaded. But it looks like I crashed it. So I'll probably call it there.
Typical when you're showing something, it
Yeah.
breaks.
So unless there are any
Can I ask
outstanding.
you a favor? If you can put in the Mila note, if you can put the link to the GUID
Oh, yeah. Yeah.
repository.
This one.
That's very powerful, and actually I think it's quite needed to do your kind of architecture. Because if not, the cross-reference between scenes would be like impossible, actually.
I wonder what would be.
You can paste it directly, and drag and drop. But
Cool.
also there's like a link in the, like the second one. It says note and then link. You can also paste it like that.
Oh, gotcha. Okay. That one's not too bad. Let me keep that there, and we can add a. Just rearrange some things.
Yeah, that's the bad stuff of Melanet.
Yeah.
To rearrange things,
Well, yeah.
the adjustment is not that. When you align things, it's not that comfortable to do. Also, I would love to have like a grid or something like that to arrange things.
Yeah, I agree. And so here are kind of the code snippets that I was showing you guys. There's the game system base that all of my game systems are built on. I have the bootstrapper here. I think the only thing that I don't have here is the scene loader. Let me take a look here.
One quick question in
Yeah.
between. When you add, because you are procedurally adding sections to the map, every section is a different scene.
No,
or
it's
not?
a different. It's an instance of a prefab that's pulled from a object pool.
Okay.
So there is. Well, if you guys want the scene loader, I can share that. later. It's just a wrapper around the addressable specifically for scenes that add convenient ways to load and unload the addressable, as well as some callback events. And that's what I'm using for the Bootstrapper. I can share that. And I can just show you real quick. In the gameplay scene, I have a level generator component here. This has a child game object called level segments, which currently only contains one level segment pool. So if we take a look at this, I have a class that I wrote called component pool base, and so this just provides it's the same thing that I use for the audio sources. You basically provide a pre-configured component, or an original component that can be a prefab, or it can be a component in a scene, and it will instantiate instances in an object pool fashion. If you guys are familiar with how object pools work, at your minimum pool count, so the X value. And when you access resources from that pool, you can determine on a instance basis your criteria for selecting another component from the pool. So in this instance, the level segments, I say if I can select this segment from the pool if the active in hierarchy is false. So if it's not available in the hierarchy. And when my level generator selects an instance, before we return the instance to the generator, we call an onset instance. So this similar to how you saw me setting the field values on the audio source in the preview, the sound previewer editor script, it sets the instance from the pool equal to the values in your original, and then you can specify your own kind of code that you want to run every time that you're returning an instance. And so I call this generate segment. And that basically takes instance of the previous level segment so that it can find the start and end transforms and attach it to the top of the previous segment.
I'm just let guys know that I'm going to take off real quick. I got to get going.
Okay. Well, thank you so much.
I do appreciate everything. It's been really helpful listening. I got to get going.
Yeah. Okay. If you
Thanks,
want to talk about it more another time, just let me know. All right, take
Definitely
care.
will. Thanks again. Bye.
Bye.
Bye. Oh.
And so you can, if I run this, so I set that pool count to 10 and a maximum of 15. And just real quick here, when we get into the game, there we go. We can see if I zoom back these aren't being, so it's using, they're not being illuminated because it's only a spotlight now, but you can see, here are the active segments. My world size defaults to six segments, and then the rest of the pool is disabled. And so these are just the instances of those prefabs, and so then they have a start point and end point, which is where the spline starts, and then it's the it's just a little sprite renderer that renders the track underneath it. And those rather than loading and unloading scenes, this was a better use of resources, and it allows me to, the level generator will look for n number of segment pools that are available on this, like as children, and so I can create other segment pools that have different variations on this level segment to allow the generator to pull from. Does that answer your question, Raphael?
Yeah, completely.
Cool.
Yes.
And so, I guess before we kind of call it, the last thing I'll say, if any part of the architecture or object patterns and stuff that you guys see here you are interested in adding to your project, I would be more than happy to work with you and help you out and get that added. Just let me know.
Thank you. Thank you.
You're welcome.
Actually, I will.
It's very
so-
interesting. It's very much stuff.
That's great. I think so. I think we'll call it there. I hope you guys have a really great evening. Thank you so much for staying on so long and asking questions and listening. And if I can help you guys in the future, just let me know. And if you have any questions afterward, feel free to just send me a PM and we can update that Milanote board going forward.
Yeah, and again, thank you very much for everything. That was a very nice preparation for everything. So thank you.
Oh, you're most welcome. Take care, guys.
Thank you very much for making all stuff together, putting it together in the Milanote.
Oh, you're welcome.
Okay.
Yeah.
Bye.
I'll go to bed now.
Yeah,
Yeah.
And see you next week.
absolutely.
Fully.
See you next week.
Take care.
Thank you.
Bye.
Bye.